Here we have the series of n plus natural log of n divided by n to the fourth plus 2n plus 1. And we want to use the limit comparison test to show that this series converges. And so, again, to use the limit comparison test, we have to come up with a series b sub n and show that the limit of b sub n over b sub n is equal to a positive finite number. And then we also have to show that b sub n converges. Then we can claim that the given series converges. So here we can just let a sub n be the given sequence here. And then just let b sub n be something similar. That we know something about. And the reason for choosing b sub n to be n over n to the fourth, this will reduce to 1 over n to the third. And we know that the series b sub n of the series 1 over n to the third is the p series with p equal to 3, and it converges. So that's why we choose this. But now we need to show that the limit of b sub n dividing by b sub n, that this is equal to a real finite positive number. And this is equal to dividing by this quotient right here. It's the same thing as multiplying by the reciprocal. And then we can arrange things a little bit. And then record that the limit of the product is just a product of limits. So, and then for this one, we can divide everything by n to the fourth. So divide the top, the bottom by n to the fourth. And then this one, we can use the L'Hopital's rule. So this becomes 1. And this is 1. And this will be 2 over n to the third. And that will be n to the fourth. And then for the limit right here, the corresponding continuous function is this. Is the x less ln x dividing by x. And if we allowed x to run to infinity, then we get infinity on the top and then infinity on the bottom. So we can use L'Hopital's rule and record that L'Hopital's rule says that this is the same if we do the take the derivative of the top and derivative of the bottom. So the derivative of x is just 1. The derivative of ln x is 1 over x. And then the derivative of x is 1. And as x approaches infinity, this will go to 0, and then we get 1 over 1, which is 1. And therefore, the this part right here this is equal to 1. And then as n approaches infinity, this will go to 0, this will go to 0. And so this part right here, this is 1, and then we have just shown that this is also 1. So for the whole thing, we get 1. And so we have just shown that the limit of a sub n over b sub n, this is equal to 1, which is a positive finite number. And then now our objective is to show the this series right here converges. And therefore we also need to show that the series b sub n converges. So we need to show that the series b sub n right here we need to show that this series right here converges. And so notice that this is the same as 1 over n to the third is a p series with p equal to 3. So it converges. By p series test. Recall that the p series test says that if we have a p series and a p is greater than 1, then the series converges. And so now we have shown two things. We've shown that the limit of a sub n divided by b sub n is equal to a real finite positive number. And we've also shown that the series b sub n converges. And therefore, we can claim that the series b sub n right here, the original series, converges. Limit comparison test, the original series converges.